Hey kiddos! Today we're going to be talking about inscribed angles, but before we get started in inscribed angles, I wanted just to refer back to central angles, so that way we have a clear understanding of what a central angle is, okay? If the vertex of an angle is located at the center of a circle, then the measure of its intercepted arc is equal to the measure of the angle, okay? So this is where we've mentioned this is circle X because X is the point in the middle. So basically, we're saying that this angle here is going to be congruent to its arc because it's a central angle. Okay, so clearly as you see here, the measurement of arc AB is equal to the measurement of angle AXB, which is 81 degrees. So therefore, measurement of arc AB is 81 degrees. I just wanted to go back over that just to make sure that you recall this information, because now we're going to talk about inscribed angles. So let us look at what is inscribed angle theorem state. It states that if an angle is inscribed in a circle, then the measure of the angle equals half the measure of its intercepted arc. So a inscribed angle, okay, as you notice is right here, okay, and it's basically an angle that is created by two chords inside of a circle, okay, where these two chords meet at a common vertex. So you notice these chords do not go through the center, okay, and they all have points that are located on the circumference of your circle. So this angle here, angle ABC, is considered an inscribed angle. So here are some formulas to help us find a few different things here. So the measurement of angle ABC, which is this angle here, is equal to the measurement of the arc AC divided by 2. Or, let's say we were looking for something else, we can simply, if you're given the angle, we can multiply that angle by 2, and that would give us the value or the measurement of the arc, okay? So these are the two different ways that we can go. We're either going to be looking for the angle, which means we're dividing the arc, or to find the arc, we would have to multiply the angle by 2. So here's our first example. The measurement of the arc AC is 80 degrees. So I'm going to put that's 80. Notice this is clearly not a central, okay? It is inscribed, and it wants us to find the measurement of angle ABC. So we're looking for the measurement of angle ABC. And to find that, I understand, hopefully, that it is half the measurement of its arc. So 80 divided by 2 leads me to 40 degrees would be the measurement of angle ABC. All right, moving on to the next part here, inscribed angles of congruent arcs. So if two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. So for example here, and make sure you're really trying to see this here, I'm looking at angle ABD, all right, that's my first inscribed angle, and the angle ACB, which is in yellow here, okay, I can note that those two angles have the exact same arc that they're sharing. They both share arc AB. So because of that, we can then state that these two angles will be congruent. So that's one visual of how you could possibly see it, where basically your inscribed angles look like they're basically intersecting each other. But you can also see it like this, okay? So again, because I see here that arc LM is marked as congruent to arc GN, then that would mean that these two inscribed angles, angle GHN and angle LKM, would have to be congruent to each other. That's all that this is simply stating. Okay, so let us look at an example here. So we are given here that the measurement of angle 1 is x, and the measurement of angle 2 is 2x minus 30. And the question here states to find the measurement of angle 1 and angle 2 and find the measurement of arc AD. So, first thing we need to see is, do these angles intersect the same arc? Because that would give us a nice piece of information that they're congruent to each other. So, if that's true, then what arc is it that they actually share? So, if I see angle 1, blue, it's in the blue, which goes from here to here, the angle. And the next one, angle ACD, also goes to those same points, which tells me then that these two do share a arc, and that would be arc AD. So, because they do share an arc, then that simply tells us that this angle is congruent to that angle. So, mathematically, we should hopefully know what to do. We're going to set them equal to each other. 2x minus 30 equals x. Now, all we have to do is solve. So I'm going to subtract x to both sides. That leaves me with positive x minus 30 equals 0. Then I'm going to box my variable, do the opposite. So I'm going to add 30 both sides. That cancels out. X equals 0 plus 30 is 30. So x is 30, which coincidentally, x is the measurement of angle 1. So the measurement of angle 1 is 30 degrees. The measurement of angle 2 is 2x minus 30. So 2 times x minus 30. We already know that x is 30. So 2 times 30 is 60. 60 minus 30 is, well, what do you know? It's 30, which technically we already knew that. And therefore now the measurement of arc AD. Well, we know that the measurement of the arc is going to be double it. So simply it would be 2 times 30. So that means the arc is 60 degrees. All right, so now let's say we're looking at inscribed angles of triangles. Yay, I know, your favorite shape. Okay, so what it's basically stating here is, if the inscribed angle of a triangle intercepts the semicircle, a semicircle, okay, and we should hopefully recall that semicircles are created by diameters. So you can see here AC is the diameter, okay, then the inscribed angle is going to be a right angle. We understand that semicircles, so basically what we're saying here is this arc would have to be 180 degrees because it's a semicircle. And we already know the rules here of inscribed angles. They're half of their arc. So half of 180 is 90. So that would be a right angle. I know that's a really bad looking right angle box. 90 degrees. That's simply what it's saying here. So arc ADC is a semicircle. So therefore, the inscribed angle ABC has to be 90 degrees. So let's look at our first example for this type of situation. Okay, so for this example, we're going to find the measurements of angles 1, 2, 3, 4, and we throw in a little extra, find the measurement of arc ED and the measurement of arc AB. All right, so let's get started. Now, please make sure that you always recall prior knowledge here. And we can see here that this shape that's created is a triangle. So I'm looking at triangle AED. Now, I can see the angle EE here is marked as 90 degrees. And the reason why is because it's inscribed at a semicircle. Okay, so that's kind of what we talked about beforehand. So let me mark what information they give us here. They tell us that arc AB is congruent to arc BD. All right, fair enough. Now, they tell us that measurement of angle 1 is 3x plus 8. Measurement of angle 2 is 12x minus 8. And we already know that the measurement of angle E here is 90 degrees. So first thing that we need to figure out is what is the value of x, so that we can figure out what the measurement of angle 1 and angle 2 is, so that we can find the others. So because, again, that's a triangle, we know that the three angles inside of a triangle add up to 180. So angle 1 plus angle 2 plus angle E is equal to 180. So I've substituted those values in, and now we can combine like terms and solve. So when we combine 3x plus 12x, that gives us 15x. 8 take away 8 is, 0, plus 90, though, is still 90, equals 180. All right, we're solving for x, so I'm going to subtract 90 to both sides. We're left with 15x equals 90. And then 90 divided by 15, because that would be our last step here, gives us the value of x to be 6. All right, so now if we plug that in to here, we're given 3 times 6 plus 8. 3 times 6 is 18. 18 plus 8 is 26 degrees. And then I'll again plug in the value of 6 for x. So you get 12 times 6 minus 8. So 12 times 6 is 72. Take away 8 is 64 degrees. So we just figured out angles 1, check, angles 2, check. Now, to figure out angles 3 and 4, we need to use some knowledge that we have here. Now, we hopefully recall that the measurement, or that arc ABD is a semicircle, which means it's 180 degrees. So therefore, if AB is congruent to DB, then that would mean that these two pieces are equal and basically cut in half. So half of 180 would mean that these arcs are both 90 degrees. Okay. So now that we know that, I can clearly see, let's deal with angle 3 first. Okay. Angle 3 is inscribed to arc BD, all right, which means it's half of that arc. So the measurement of angle 3 would be half, or 90 divided by 2, which is 45 degrees. All right, well, coincidentally, the measurement of angle 4 is going to be congruent to that, because those arcs are congruent, which was another theorem that we've talked about. So notice this is kind of putting everything all in one. So now we have figured out what angle 3 and angle 4 is. So now let's look for our arcs. Arc ED. ED. Let me highlight it here. ED is this arc here, and its inscribed angle is angle 1. Angle 1 is 26. So I double that to get the arc ED. So 26 times 2 tells us that arc ED is 52 degrees. And then the last one was arc AB, which we already found because it's half of the semicircle, so that's 90 degrees. I know it's a lot in this problem, so we probably pretty much put it all in one for this one, but you guys can handle it. All right, so here we are going to talk about in a quadrilateral, okay, this is a four-sided polygon, being inscribed inside of a circle. If a quadrilateral is inscribed in a circle, which you can see that has happened here, then its opposites angles are supplementary. We know supplementary basically means that it adds up to 180. So we have quadrilateral ABCD. It's inscribed in circle P. So therefore, A and C are equal to 180, and angles B and D are equal to 180. Probably kind of didn't mark those right there, because they're not congruent. They're supplementary. Sorry. So let us look at this next problem. they tell us that the measurement of angle WX right here, or WX of W, I don't know my letters. Measurement of angle W is 95. Then they tell us that the measurement of angle WXY, so that's the one in blue, is 120. Notice that arc overlaps the green arc. Keep that in mind. Find the measurement of angle Z, angle X, arc, ZYX, and angle Y. Now, the easiest thing, or the first part we're going to start with, is the concept that because we have a quadrilateral inside of here, opposite angles are supplementary. So, to figure out the measurement of angle Y, okay, all we have to do is take 180 and subtract it from angle W, which they gave us as 95, to get that answer. So that concludes that angle Y is 85 degrees. So check, we got that one. Okay, now let's see if we can use this arc information that they gave us, the blue arc, okay, to help us find something. Can anyone figure out where is the inscribed angle of that arc? Hopefully you guys are saying that angle Z here is the inscribed. So notice it goes from here to here, which is the distance of the blue arc. So therefore, that's my inscribed angle to that arc, WXY. We know inscribed angles are half of the measure of their arc. So all we have to do is take half of 120, which leads us to 60 degrees. So angle Z is 60 degrees. Now we can go back to the concept that because we have a quadrilateral, opposite angles are supplementary to figure out what angle X is. And to figure out angle X, we're going to take 180 and we're going to subtract 60 from it. And we get the angle X is 120 degrees. Check. So now the question is asking for what is the measurement of arc ZYX? And that is the angle ZYX. That's a typo. It's supposed to say ZWX. We're supposed to be looking for the one in green. Okay? ZWX. So, to find ZWX, which is, yes, like I said, the one in green, ZWX, again, we're looking for, does it have an inscribed angle? And hopefully you see that angle Y inscribes it. So, we know the measurement of angle Y is 85 degrees. So that angle, we would have to double to get its arc. So 85 times 2 leads that angle ZWX is 170 degrees. And the last concept that I want to talk about today is talking about the measurement of radians. We have degrees and radians. You guys have seen that before in our calculators, okay? Radians are another unit of measurement for angles and arcs. A radian is the angle that would be created by wrapping the radius around the edge of a circle. There are 2 pi radians in each circle. So, to get the measurement of an arc in radians, all you have to do is take the measurement of the arc in degrees and multiply it by 2 pi divided by 360. So what you see here is we have a central angle, okay, going back to it so you don't forget, have a central angle here, and we know that the central angle is equal to its arc. So therefore, if the central angle is 81 degrees, then its arc is also 81 degrees. So to figure out the radians, all we would have to do is 81 degrees times 2 pi over 360, and we get, be sure to use the actual pi button, you get 1.41, we'll just round to the hundredth there, 0.41, and we would always have to write radians. Okay, so I just want to quickly show you guys how to make that conversion from degrees to radians, it is simply by taking the degree and multiplying it by 2 pi over 360. And yes, please make sure that you write this down somewhere on your paper so that I can check for it. Ciao!